Well, hello, calculus students and seekers of general truths. In this video, we will brush up a little bit more on our graphing skills, making your mind do that work, making your mind exercise that muscle to visualize and to think, transfer between the algebraic and the graphical. And here we have a piecewise graph with 3 different parts. And when we approach these problems, it's maybe helpful just to think what are each of the individual parts look like, and then we will apply the restrictions a little bit. So the first part here, this is a semicircle that is centered at 0 and has a radius of 5. All right, so I won't go into too much to that right now, but you should review how to graph circles and semicircles, but this is effectively what it is. Okay, so I'm going to just draw all of the parts here, and then we will deal with the restrictions later. So the first part, again, is a semicircle with a radius of 5, and it is centered at the origin. Okay, so it's going to look like this. It's going to be tempting to call this a parabola, but it is not. It is a semicircle. The second part, we're going to need to do a little bit more work. We can factor this out as x minus 5 times x plus 5. All of this over x minus 5. So we can see that these parts here will cancel, and this is just x plus 5, okay, with a hole at 5. Because if we were to put 5 into the original, it would fail. Okay, so this is the function x plus 5 with a hole at x equals 5. Okay, and I'm going to change this color to blue here. So x plus 5 is a graph with a slope of 1, right? And the y-intercept of 5. So it's going to look something like this with a hole, of course, at x equals 5. Okay, so it's going to look like that and such. And then it's going to also extend in the other direction as well. So it's going to go kind of like this. Okay, and the last part is just a dot. When x equals 5, you have 0. So here we know that there's a dot right there. Okay. Now, if we take a look at all 3 of these parts together, it's not a function. There's all kinds of issues with this. So now we can think about the restrictions, and I'll just redraw the graph here. Okay. So the first part, the red part of the red graph right here, only applies when x is less than 0. So we're only going to look at the part that's the red part, but when x is less than 0. And notice the boundaries here matter. It's not x equals or less than 0. It's x less than 0. So this point here is 5. That's my tick mark, but there's a hole there, and then there's this curve here. Okay, it ends at negative 5. The blue part applies if x is greater than or equal to 0, but not equal to 5. So the blue actually fills in the graph, right? Because when we put in 0 for x, we actually get positive 5. It extends upwards. There's a hole there, and then it keeps on going. And that occurs at 5. And then when x equals 5, you have a dot at 0. Okay. So there you have it. Okay, so this is a very unusual looking graph, I know. It is a very unusual looking function, but it is a function nonetheless. One thing to point out here, that the domain of this function is all real numbers greater than or equal to negative 5. So any input negative 5 or greater has an output, even if there's a hole here, because this dot takes care of that particular point. Okay, and the range is all positive numbers, except for 10. Right? So when the coordinate of this hole right here is actually 5, 10. Okay, so I'm not asking, this particular question doesn't ask for range and domain, but it's good for you to think of it this way. Part of the review work, part of the summer practice is for you to kind of shake off the rust and to get your minds engaged again in doing these problems. Graphing it this way actually takes a little bit of time, but it is still superior to using a calculator, because there's no function that can, no graphing tool that can really provide this level of detail for you. As always, keep working hard. Ask for help when you need it. Thank you for watching and have a wonderful day.